Okay, the purpose of this video is to work through Lab 1166, in particular problem 1. So basically what it's doing is given an IP address and subnet mask, we're calculating information about a particular subnet. This is very similar to the problems that I've been giving you, other than as far as doing the subnet calculations, I typically tell you how many subnets we need or the size of the subnets, and you figure out the subnet mask from that. In this case, they give you a old or original subnet mask, which is 255, 255, 255.0. So that's a normal Class C subnet mask, where we have the division point at the decimal point between the third and fourth octet. Now then, what they're doing is telling you that you're using a new subnet mask, which is 255, 255, 255, 224. So the first thing we need to do is take that 224 and convert it to binary. And that is 1, 1, 1, 0, 0, 0, 0, 0. One thing that I pointed out in the lecture is that a valid subnet mask is a whole bunch of ones followed by a whole bunch of zeros. So prior to this 224, we have 255.255.255, which is 24 ones, followed by 111, and then a bunch of zeros. So this is our new subnet portion, and this, like always, is the host portion. Now then, looking at the questions, they ask us how many subnet bits there are. Well, in this case, going from the original subnet mask to the new one, is we have 3 bits there. They ask us, borrowing 3 bits or using 3 bits, how many subnets do we get? So if we have 3 bits that can have 2 possible values, the possible number of combinations is 2 to the third, which is 8. So the answer to the second question, how many subnets are created? 8. The third question is, how big are each of these subnets, or how many host bits are there? And I showed right here that the answer to that question is 5. The next question is, how many hosts do we have per subnet? So if we have 5 host bits that can have 2 different values, then that's 2 to the n, and it's the number of hosts, so we have to subtract 2. So why do we have to subtract 2? Because within any subnet, the first value with all the host bits set to 0 is the network number. The last value, all the bits set to 1, is the broadcast. So this is usable IP addresses. 2 to the 5th is 32, minus 2 is 30. So that's how many usable hosts we can have. So that answers the first 4 questions. Now then, if we look at the last 4 questions, and this is very similar to the beginning network math problems I give you, is we have 192.168.200.139. And what we need to do is, one way to get this, the technical way to get this, is to AND it with the subnet mask, which is 255.255.225.224. Now then, one thing we could do is we could convert all 32 bits to binary. We could AND them together and then we could convert them back to get the answer for the first question, the network address. But one thing that you should remember is anything ANDed with 1, if we're talking about bits, is itself. That is 0 and 1 is 0. 1 and 1 is 1. So we get back whatever we had originally. So in this case, we convert the 192 to binary, the 255, we would get 192 back. We get binary, we convert it. So we don't really have to do anything other than bring down those first 3 octets. Now then, what we really do need to do though is take the 139, because this transition in the subnet mask happens in the last octet, and 139 is 10001011, and as we pointed out before, 224 is 111000000. Now if we do a bitwise AND on these, ANDing things with 1, we get back whatever the original value was, so 100. And ANDing anything with 0 is going to give us 0 back. And then if we convert that to binary, we get 128. So another way, instead of doing the bitwise AND, that may be a little easier to remember and a little easier to do the quote math, is the network number is the IP address with all the host bits set to 0. So here we have our subnet that this is on, and then here we have all the host bits set to 0. Likewise, for the broadcast address, we have our subnet number, or our subnet value, and the broadcast is the IP address for the IP address that has all of its host bits set to 1. 1, 2, 3, 4, 5. So that is the binary representation of the last octet for the subnet. So the 192.168.200 comes down as is, and 100.11111 is 159. So this is the network number, and this, the 159, is the broadcast. Now, to answer the last 2 questions, that is, what is the first and last usable IP? Well, the first one is going to be 1 more than the network number, and the last usable host is going to be 1 less than the broadcast. So that is how you go through and work, in this case, problem 1 on lab 11.6.6.